it first though, so here we go. Welcome everyone, and thanks for connecting with us today. We're super excited to have Neil Pergar here with us from US Steel. My name's Nick, and I'm with the Northwest Tri-County Intermediate Unit. And I want to give a shout out to the Northwest PA Job Connect, which is our local workforce development board. We wouldn't be able to have these connections with Neil or other professionals if it wasn't for them. So a special thanks to them. And we are super excited to have Neil with us. And I'm going to send Neil live here. He works for US Steel, and he's a project engineer. So Neil, tell us a little bit about maybe US Steel, and then what exactly is a project engineer?
Thanks for having me. At US Steel, we just like the name says, we produce steel. So I work at the Edgar Thomson plant in Braddock, and we produce on average about 2 million tons of steel a year in flat roll steel. And just for give you an idea, your car on average weighs about 2 tons. So take about 1.5 million cars, and that's how much we produce. Here at the steel making facility, we do everything from take the raw materials, the iron ore pellets. We take the lump coke that's made up the river at Clairton. We combine those materials along with any other alloying additives into the steel, and then we produce the final product and cast it into 8-inch thick slabs of steel. So our product is then sent down the river to our urban works, where they roll the steel into specific thicknesses and specific coatings for our customers.
Okay.
Typically, our steel is used to make cars. For example, the exterior shell of the cars. Rolled steel, like make up aerosol cans, your washer dryer, refrigerators, and so that's what we do at US Steel. And my job as a project engineer is to facilitate the projects, all the capital projects that typically over $1 million. That would be improvements or repairs, major repairs to the steelmaking facilities.
Okay, so we had a connection a while back with somebody who works, one of the engineers that worked in the Clairton, the facility. They were making the coke up there, so it gets shipped downriver to you guys, and you guys are the actual users of iron ore and coke to make steel.
Yes, that's correct. Yes, so yeah, the coke fuels our blast furnaces, which are the machines to make the iron. And then that's combined with scrap, which is recycled steel, to then make steel.
Okay, so you guys use recycled steel?
Yes, we do. On average, about 20% of our product is recycled steel. Some facilities, steelmaking facilities like our Fairfield, Alabama facility, is 100%.
Wow. Wow, that's fascinating. So as a project engineer, you mentioned that you make sure that there's the machines are reliable and they're functioning. Is that your exclusive role? Is to make sure things are working?
My primary role in the project engineering group, which is a fairly small group, but really we are to make the capital improvements so that things are more reliable, that we want it to, whatever we install in our capital improvements will last 30, 40, 50 years. For example, we just did a project to do a major rebuild of a blast furnace that was built in 1930. And so obviously, aging facility, a lot of work needed done, but we pinpointed the improvements that really needed done during some downtime, and did all the repairs we needed, to avoid having another major shutdown for another 20 years. So
yeah.
Other projects, other targeted replacements of components in the steelmaking facilities, all the capital improvements, then to hand over to the equipment owners which then operate it, which are my customers, the operators, the maintenance, and make sure that we're delivering the products that meet their needs and are sustainable, and then do all the documentation, and then make sure they're supported for the long term.
That's it. I see. So for somebody out there listening, and I want to give a shout out to our attendees, somewhere on our screen, or somewhere on your screen, if Neil or I are saying anything and you'd like to ask a question, anytime throughout this conversation, you can ask that question. It's a little chat bubble with a question mark in there. Feel free to click on that and add your question in. Neil, I want to back up for a second. I know from my experience, there's 3 types of resources generally. You have natural resources, which are what you find outside. You have human resources, which are people, and then you have capital resources, which are, what are capital resources?
But typically, what we refer to as capital resources would be monetary. So it would be the funding which our board of directors releases yearly to fund improvements, and we prioritize lists of hundreds of projects throughout the corporation that need to be funded to keep our facility sustainable, keep improving, the environmental safety, obviously the top priorities of improving, and just overall infrastructure typically. And so that, the projects here at my plant at Edgar Thompson and Braddock, obviously I want to see done. I want to see all of them. So work with the departments to best prioritize those, why they need them. We do risk assessments with them, and also form the budgeting, which is very important, big part of my job. The timeline and budgeting of these jobs. How long is it going to take? How much is it going to cost? Every time I talk to my boss, that's his 2 biggest questions. I want to talk all technical details because that's what I'm trained to do as an engineer, as a problem solver. But the biggest thing is on time, on budget, delivering projects, and that factors in big with the capital planning, planning the portfolio of, we're say give an order of magnitude, maybe we have $1 billion of capital for a year. We need to prioritize that, and it's amazing how fast that can get prioritized and taken, and some other projects drop off that don't make the cut. So
yeah.
So that's we're responsible for managing that and making sure that it's used wisely, and it's going to be
the most bangs for your buck. So Neil, let's shift gears a little bit in terms of if somebody was interested in a line of work as a project engineer, what would you say your interests and abilities are to make you an asset to U.S. Steel?
So anybody looking to get in the field, certainly math skills, but also written and verbal are huge, because really a project engineer is not the decision maker, but is a facilitator to make the best decisions and create the best product. So I'll be the one. So for example, if my customer, just to make it understandable, he wants to build a house, and you would hire a project manager typically if it's high value, the stakes are high, and you need some engineering effort built into it. So my customer says he wants to build a house, and so I'll start asking questions and get the right people involved to answer all those questions, to create the design of, okay, well, how many bedrooms? Well, how many bathrooms? What kind of power supply are we looking at? What, let's go, is it a port foundation? Is this a cinder block? Are we doing stucco walls or drywall, or, just all those details we really dig into. And sometimes I'll employ an engineering firm to help with that if I can't support that with my background and knowledge. And they'll take all the customer requirements down to the how many mils of paint and what kind of paint you want on that, and then take that for bid. Look at each bid and compare every line. Does that qualify the customer's requirements? Because in the end, it's the customer making the decision, not the project manager. But it's my job to facilitate that and document that and make sure that the money spent prudently and the customer's needs are met. Excuse me. So kind of went off a tangent, but
No.
that really that's what I want to emphasize. The project manager is a facilitator of the project, not so much a decision maker. However, if it's in my wheelhouse, if I have knowledge of the process or the equipment, I can certainly facilitate the decisions. And my job to also make sure that everything is put on the table for the customer. In my case, it is my colleagues in operations and maintenance. Sometimes as a project manager, I may be an outside firm working for a customer, for example, Duquesne Light or anything, building a hospital, whatever it is that I'm hired to do to facilitate to make sure the customer's needs are met.
So is it fair to say that you have to have top-notch organizational skills? Would you say that's an ability you have to have?
That's number one on my list, absolutely. So I don't know how many times on a project we're nearing the end, and somebody, one of the stakeholders may come up to me and ask, who decided that you were going to do that? And I have to go back to a meeting minute or notes or a change log where I said, there was a meeting this day and your boss said that we were going to do this. And so, you have to document everything from meeting minutes to drawings, to I take pictures everywhere, pictures, videos, everything, because you want to make sure everybody understands, of course, what the plan is and what the final outcome is, and even the before state. We had a project last year where there were some structural pieces that were there, and then after the project they were actually missing, and it caused us some big time issues. And luckily my pictures we went back to and documented, and we got everything resolved. But the documentation is probably the biggest part of my job in organization.
And would you say that you spend a lot, or what percentage of your time would you say you spend in front of a computer as compared to working on the floor, hands-on, etc.?
So good question. So it depends on your field of work and where you are a project manager, but it's probably 70-30, 70% in the office, 30% in the field. And I'm fortunate that I do work at the site, so I may be working on a drawing or markups or a scope of work write-up where, I don't have that picture. I don't have, I need to go look at this, and or I need to go talk to this guy, or obviously we're doing it remotely these days, but yeah, so I get bored in the office myself, so I try to make it at least 30% in the field. So again, we're at an industrial site here as well, so there are project managers in residential and commercial sites as well, where it may be a little different atmosphere, where it may be more office work. But in an industrial setting, probably you're going to see more in the field opportunities, which I love. I wouldn't have it any other way.
That's cool. That's cool. So talk to us, about whenever you're sitting in front of that computer and you're running those organizational skills and putting those to work. What are some of those hard skills? Maybe whether it's a particular application on a computer, a specific discipline like algebra. What are some of those job-related skills that are essential to you?
Yeah, for sure. So I do spreadsheets a lot. So budgeting and organization of like a log of, I have a log for every project for any change requests that come to me. Hey, I want to add I want to add this or that to the project. And even if I say no, I list the request, I still list it as rejected and the reason why. So everybody can see that in the team and understand, what was brought to the table, why it was or was not included in the project. And uh, the big part of project engineering, as well as any engineering, is drawings. So this is kind of an old one, but so understanding how to read a drawing, whether it be mechanical, structural, electrical, a piping diagram, is huge because you understand what's going on. And obviously it's the key documentation given to the customer, especially in our setting, an industrial setting, to understand all the components of the equipment they're getting and what the system is doing. In some cases, I mean, this is kind of a structural drawing here, but the amount of detail that are in these drawings, if you were to go just replicate something like this, and of course back in the day, this is from the 70s, this was hand drawn, so that takes a long time. Today we have computers, and I work on drawings almost every day, little snippets of it. Just because I have a drafting background, I'm able to support projects in that manner. However, a lot of times, bigger projects, I'll employ an engineering firm. I'm not a structural engineer where I'm not able to approve drawings or bless them to say that is structurally sound. But I'll hire a firm to do that, or I can even write it up and then give it to a structural engineer and say, "Can you give this your blessing?"
Sure.
But understanding all the symbols and what's going on, there are so many different, whether it be welding symbols or structural that are commonly used in drawings, that it's huge knowing them. It's very important. So those are just a couple of the key ones.
Okay, so I want to come back to that, but I also want to share out to our attendees that we'll be shifting gears a little with Neil. If you have any questions for him or anything that he's talking about or myself, don't hesitate to throw those in there. Neil, back up a little bit. You talk about drafting. So is most of your drafting on a computer or is it longhand?
Yeah, absolutely. Yeah, it's all on the computer. Ever since the 90s, for the most part, it's been on the computer, and thank God, because some of the detailed drawings and drafting by hand is not as forgiving for sure. Yep.
Okay, so what's the most common computer-aided drafting application that you use?
AutoCAD is the typical one used. So, and there's different versions, but we have each available. US Steel typically does not do a SolidWorks, or I forget the third one that's commonly used, but for the most part, AutoCAD is the most universal that I've seen engineering firms use.
Gotcha. So let's shift gears to your education. Talk to us about your educational path. Does your position require any formal education? And if it does or does not, what would help if somebody wanted to get into that role?
So I am educated as a mechanical engineer. I went to Penn State for mechanical engineering. And that's based on how our structure is as a project management organization. That's the ideal education for what we're asked to do to support projects, to understand, have a technical background, be able to, support the technical side of project management, as well as the accounting part of it, and also written and verbal communications. Certainly also engineering technology. There are engineering technology programs. I believe some universities, and Nick, you may know this, that have project management. I know there's a master's in project management. I don't know if there's a bachelor's, but certainly that could be a background in commercial or residential project management. But for our organization, certainly a bachelor's in engineering is preferred. I also have an MBA. That applied, I guess, to my previous work at US Steel, being a manager in maintenance. Also, project management professional certification is also um, a really good certification to have as project manager. It's kind of the standard for project managers, especially for government work. If you're doing work for the government, they follow strict adherence to their standards. At U.S. Steel, we don't. We kind of tailor those to each project. But the project management professional certification I got this past year, and you have to have a bachelor's or an equivalent experience to be a candidate, and then you take a week-long course. It's a boot camp to then prepare for the exam and then take the exam.
Cool. So tell us, share with us something that maybe you might feel that the audience would say, "Wow, that's pretty interesting. I can't believe that actually happened." You know, anything fun that's happened in the beginning of your career, or maybe towards the part of your career you're in now. Anything interesting?
You know, yeah. I just feel it's interesting the history of our plant. So we're from Pittsburgh, the Steel City, and most people, the common belief is that we don't make steel, but we definitely do. It's certainly not to the degree it was in the 50s and earlier. Our plant is the first and last, actually. It was built in 1875 by Andrew Carnegie. It was his first steel mill, and then they built steel mills up and down the Mon River for the next 75 years and or longer. And now we're the last in the Mon Valley, and we still do very well. And also, you know, for the last 125 years, we have not stopped improving, especially environmental compliance is obviously big for us, and just to be part of that history is big for me. My grandfather worked at Westinghouse, which is actually just down the road, and just being part of American manufacturing to me is, you know, to me it's just huge, because it's kind of, you know, it was the American identity at least, but. Yeah. And also, you know, the history of our facility of supporting World War II, the steel production, you know, certainly outpaced the Germans and Japanese, and certainly just being part of that history and looking back, I'm looking at a drawing on my wall that's from just pre-war, just kind of a layout of the plant, and it's pretty cool to be, you know, part of that and continuously improving that.
Sure. And one of the questions I think we always get from our audience is that, you know, if somebody wanted to move into a career as an engineer, even in your line of work, what advice could you give to anybody in high school, whether it's 6 to 12, some classes that you think that maybe they should check out to see, is this something I like? Because engineers do it a lot.
Yeah, so the obvious is engineering class that I was able to take in high school, and they did have an AutoCAD program. We had an AutoCAD lab, which was awesome. So that kind of got me started. Metalworking, woodworking, especially for our industry, because most things are made of steel here. So just understanding. I mean, obviously, I don't weld, but just understanding the process that it takes to do that, you know, welding, machining work, metalworking, again, at least for U.S. Steel. But if you're going to go into commercial, residential type engineering, yeah, woodworking even, just understanding how things are built really goes a long way to then try to put it on paper and explain, because when an engineer, you know, designs something, they're designing something typically for a constructor, a fabricator, and that's going to make that in a metal shop or wood shop or whatever it is. And, you know, you just look at the designs and every detail that needs to be on there, down to the inch. You need to understand, you know, I've never seen a perfect design, and it becomes perfect after it goes to the constructor the fabricator, then the constructor, and then they point out, say, you know, you say this here, but like this doesn't match up. This isn't going to fit. You know, there are so many details. Again, down to every nut and bolt that as it's put together, that needs to all work together. And it's amazing how many. This is the biggest eye-opening thing to me for engineering is the amount of detail that's required. And a lot of times the stakes are high. If this doesn't match up in engineering school, they always refer to the classic blunder of I believe it was the International Space Station, where I think it was Americans and possibly one of the European countries coming together for two pieces of it. But the ultimate blunder was one side was in inches in English units, and then the other side that was trying to bring together was in metric, and it cost millions of dollars. Obviously, the stakes were really high there. I typically don't deal with stakes that high. However, if a bad design goes to the field, it could cost a lot of money. So
yeah, you think they would have ironed out that detail before they sent that up?
It's amazing. It's amazing. That's why communication is key, and having people double check your work is key. Don't just put a design out there and say, "Hey, we're going to build it now."
So would you say that your English language arts skills, your writing, your speaking and listening, are those pretty important in your role? Or?
Yeah. So the like the Teams call we're having right now and the meeting we're having right now is key to my job. And like I said, collaboration. Whether we're reviewing a design, I had a call about an hour ago. We had a controls package delivered to our R&D facility, and we wanted to plan the next steps of installation. Do they need an electrician on site? Do they need, and the equipment owner was there who, you know, is in charge of the R&D facility, making sure he has all the support he needs, the vendor has all the support that he needs, and that even IT, make sure our cybersecurity folks are engaged with how we're connecting it to the network. All of that kind of goes through. I'm the first point of contact between the vendor and the customer, and making sure that all the bases are covered. We have standards and checklists and guidelines to kind of make sure that I don't forget anything. But every project is different, and that's what I really love about it. I worked in maintenance here at this facility for about 12 years, and so you're changing filters, you're changing pumps, you're replacing, repairing things, but you never really get to as many opportunities as make improvements. Now with my job, that's all we do, is to make the improvements and major repairs. So I just love kind of, you know, being able to make my mark that way and facilitate.
I think that's super admirable that you're working for an organization that's been in a foundation of America for so many years, and that's has to be a good feeling to be able to continue improving that. So I want to respect your time, Neil, and I want to thank you. We're at 12:28. Would you have any like to share any parting words with our audience or our kiddos that are in school or maybe from home?
Yeah, absolutely. Like I said, I appreciate your guys' time and attention, and the biggest thing I guess with any job, it's what you make of it, really. And I think you just gotta obviously you gotta like what you do and kind of make it your own. And even it doesn't matter if you're mopping floors or if you're designing buildings. You gotta make it your own, but also engage everybody in your team. You're going to be working in teams. You know, 99% of the workforce, and you just understand engaging everybody and bringing together all their ideas and respecting them is key, because nobody can do it alone. And if you find yourself in a management role, absolutely lean on and empower those people, because if you make it a relationship of what's called, you know, force direct in some of our management classes, it never works. It's a win-lose situation, and you know, your employees will not engage. They will not respond well, and you have to give them their you know, the freedom of their ideas to flow as well. And collaboration is the win-win, is the win-win relationship with customers, teammates, whoever you work with.
Yeah. And I think that is super important, that you can focus a lot on the hard skills, you know, the ins and outs of knowing computer animated drafting, whatever you go into, but those people skills are super, probably the most important. So with that, I want to say thank you to our audience for connecting today. And I want to say thank you to Neil for also connecting. This session is recorded, and we are going to post it onto our website. So keep an eye out on that website, and I hope you all stay happy and healthy. Take care.